All right, let's just make sure we go through it. For anybody that needs it, factor, it just had a GCF, just a GCF, just a GCF, and nothing. And we're just going to think of it as one big happy fraction because we're multiplying. And now we know we're looking for stating restrictions, so we're dependent here, which is where this one comes from, and here, which is where this one comes from. Now I'm going to cross out my like factors, and I'm going to get 2 times 4. Now, you could just write 2 times 4, but I mean, we know that 2 times 4 is 8, so it makes more sense to give an answer of 8. If this had been 2 and x plus 3, we would leave it in factored form. But 2 times 4 is 8, so we would just call it 8 over 3. All right, let's move on to the last two. It's division for you. So again, it's dependent on Happy Factoring Friday. Factoring Friday. The first step is to factor each polynomial in the numerator and the denominator and state any restrictions on your denominators. I'll explain that in a minute. There's a few more restrictions than normal. Okay? All right, are we ready? X squared minus 2x minus 35. Factors of negative 35 that add to negative 2. Negative. What are we going to do? Factors of 35 that add to negative 2.
7, negative 5.
Don't we need the 5 to be positive, though, right? Because it has to add to negative 2. Just be careful with the signage there. In the denominator, I can take out a GCF of x squared. Do you agree? Just an x squared. Every variable that they share to the lowest power that's there. Divide. And now we're going to come over here and factor this whole second fraction. 7, x minus 7, over GCF. What do we have? Can I go a little further here? I see a difference of 2 perfect squares. So I'm going to take it a little bit further. Stay with me, guys. We still have 2 more to do. This is 2x minus 3 and 2x plus 3. Now, look at all... Folks, I need your attention, please. The denominators. Think about this. I'm dividing 2 fractions. Who's the denominator in this first fraction? The denominator, this guy right here, right? So that piece seems very obvious that that would be a restriction. So x cannot be x squared can't be 0, so x cannot be 0. And 2x minus 3 cannot be 0. Which means what? X couldn't be what? We might have to write that out. So if 2x minus 3 is not allowed to be 0, because that's one of my restrictions, add the 3 and divide by 2. So 3/2 needs to join the list. That takes care of these 2 restrictions. The problem with division of fractions is, guess what? This whole second fraction is my denominator. So not only do I need restrictions from the original denominator of the denominator, I need restrictions of the numerator from the denominator. How crazy is that? So I need to do the restrictions on the bottom of the first, that's this guy, and the entire second fraction, because the whole second fraction is really what I'm dividing by. And if any part of it is 0, I'm in trouble. So what I have to do is I also have to look up here and say, 7, you're not invited. And down here, x, you can't be 0. Well, I've already got it. 2x minus 3, you can't be 0. Well, I've already got it. And 2x plus 3, you're not allowed to be 0. What would that give me? Negative 3/2. So we get more restrictions because not only am I looking at just the denominators, I'm looking at the entire second fraction as my real denominator to the entire problem. Okay? So that's that little added level of difficulty with the multiple choice. You have to be very, very careful on those. All right, step 2. Let's get to dividing by fractions. What do? You know what we do. You learned it back in middle school. Keep, change, flip. Okay? And what that means is that when we are dividing two fractions, we can simplify it to multiply by the reciprocal. So it's stated here, division of fractions is multiplication by the reciprocal. Keep the first. So when I say keep the first, I'm talking about this whole first fraction in factored form. Rewrite it. Take the time to write each line. That's my first step. Change the division to multiplication. So right here, where I have division, it becomes multiplication, which means that I can just have one big happy fraction. Right? And finally, I'm going to flip this second fraction up here. So all of this mess that was originally in my denominator becomes my new what? Numerator. So the 2x minus 3, the x, and the 2x plus 3 all move upstairs. And my old numerator of my divisor becomes my new joining the bottom in the denominator. Now, it's important to do your restrictions before you do that, just so you don't miss anybody. And now go ahead and divide out the common factors. X minus 7 with x minus 7. 2x minus 3 with 2x minus 3. X with x squared, sort of. I still have one x down there. And I think that's all I can do. Does anybody see anything else?
I'm so lost.
Take a minute. Anybody see anything else that we can cancel? So what's left in the numerator? The x plus 5 and the 2x plus 3. In the denominator, I still have one x. Don't lose that guy. And a 7, so I just have a 7x. And that would be my simplified version. This takes a little practice, but let's review the steps. The first step is to do what? Factor, and that's really like 4 problems in one. You've got to factor, 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 everything you can factor. And state restrictions. What are my restrictions on? The denominator of the first, that's the bottom, and the entire second fraction. Anything that makes that 0 is not allowed. The first step is the longest. The second step, what do we do when we divide with fractions? We are going to keep the first fraction, change division to multiplication, and flip this second fraction here. This was the flip of it. Only the second fraction flips. So this old denominator becomes the numerator piece. The old numerator moves down below. And then we cross out any like factors, and we're right back to where we were with multiplying. Okay, so dividing is really multiplying and then simplifying too. So it really ties everything together. Now sometimes on the test and on your review, because you picked up the test review today and I want you to do that front side for homework, this looks like a plus sign, doesn't it? Almost. But what's the word right above it? And that's how it'll be on your test review and on your test. So be careful with that. If it says divide, that's really division. All right, let's do this one together and then I'll let you finish 10 on your own. Number 9, factor. GCF is first. What's there?
X plus
3 times x plus 4. GCF down below? Definitely. I can take out a 2. That's all I can do. I'm going to leave division for a minute, and I'm going to factor again over here. Factors of 16 that add to 8 are 4 and 4, both positive. Or it's a perfect square trinomial. Some might want to write that as x plus 4 quantity squared. I like to just write it all out when I'm working with these. That way, if I cancel one, I don't lose anything. Divide by factors of 16 again that add this time to negative 8. Who are they? Perfect. Restrictions is the hardest piece, guys. Restrictions. I've got to look here. Can 2 be 0? No, I'm not going to worry about that. 2 is 2. Can x minus 4? Oh, if x is what? Positive 4, not allowed. Now I have to go to my second fraction and the entire fraction. So look at the top first. And then I already have these guys covered because it's the same factor. So I only get the 2 restrictions here because there's a lot of similar fractions or factors. Now we're going to rewrite it as multiplication. We keep the first, change to multiplication. So now I'm just going to make one big happy fraction and flip reciprocal the second. We're ready to cross out any like factors. So I can move down the line on the top. That might be the easiest way. 3. Is there anything down here that could cancel with a 3? Divide out with a 3? No. So he's there to stay. X plus 4. Yes. Can I cross this one out too? No, he's not squared. There's not 2 of them up there. So only one of them divides out. X minus 4. Oh yeah. Got him too. What about x minus 4 with an x plus 4? They look similar. Can I cancel it out and say it's negative 1?
No.
No. They're not the same number. Put in a number for x and see what I mean. What if it's 5? 5 minus 4 is 1. 5 plus 5 is 9. 5 plus 4 is 9. 1 is not 9. 1 is not negative 9. They're not related. You can't cancel anything further. So we're pretty much done. We have a 3 and an x minus 4 in the numerator. We have a 2 and an x plus 4 downstairs. Final answer. Don't forget you've got your restrictions. Okay, you try 10.
Yeah.
So what was the final answer for 9?
You have 3 restrictions, and there's a 3 in your answer. Did you get it right? All right, how'd you do?
Great. And we were supposed to simplify it to the
Oh, we were supposed to
simplify it to the best of its abilities.
well, you should simplify it.
Remember, you want to divide out all like factors, even if it's just a 4. 4 over 4 is 1. Just like an x minus 4 over an x minus 4 is 1.